If you want to build AI agents that feel magical, you have to master how your frontend talks to your backend. Today, we are looking at module 1.1, REST versus RPC versus WebSockets. Because we are building in Python, we will be using FastAPI. FastAPI is incredibly fast. It handles REST elegantly, and it has native support for asynchronous WebSockets. But before we write any code, we need a mental model. Imagine your client application, your UI, is a customer at high-end restaurant. Your FastAPI backend is the kitchen. The architecture you choose dictates exactly how you talk to the chef. Let's break them down. First, we have REST, representational state transfer. In our restaurant analogy, REST is the standard menu. You sit at a table, write down your order, hand it to a waiter. The waiter walks to the kitchen, waits for the dish, and brings it back. REST is noun-centric. You don't tell the kitchen how to cook. You just ask for the resource. You use standard HTTP verbs. Get to fetch your chat history, post to create a new agent, delete to wipe a session. But most important concept here is statelessness. The kitchen has amnesia. It doesn't remember your previous orders. Every single time you send a request, you have to include all your context, like your authentication token. So the backend knows exactly who you are and what you want. For AI engineering, REST is your control plane. You use it for CRUD operations, login to users, loading past conversations, or saving agent configurations. Next is RPC, or remote procedure call. If REST is a menu, RPC is having a direct walkie-talkie to the chef. You aren't ordering a finished meal, you are issuing specific commands. Chop the onions, preheat the oven, calculate the bill. While REST is about nouns and resources, RPC is about verbs and actions. It allows your code to execute a function on a remote server as if you are running locally on your own machine. Modern high-performance systems often use gRPC, which passes compressed data back and forth incredibly fast. Where do we use this in AI? Microservices. When your main FastAPI orchestrator needs to trigger a heavy RAG pipeline or tell a dedicated Python worker to execute a LangChain tool, RPC is the lightning fast, tightly coupled way to get it done. Finally, we have WebSockets. This is the absolute lifeblood of modern AI user experiences. Forget the waiter, forget the walkie-talkie. With WebSockets, you are sitting right at the chef's table. The connection is persistent and full duplex. Both you and the chef can talk to each other at the exact same time without asking for permission. It starts as a standard HTTP request, but it asks the server to upgrade. Once the server agrees, a persistent TCP pipe stays open until you leave the restaurant. For agentic engineering, WebSockets solve three massive problems. 1. Streaming tokens. When an LLM generates a response, it takes time. WebSockets let you stream those tokens to the UI instantly, so the user isn't staring at a loading spinner. 2. Intermediate states. If your LangGraph agent is searching the web or writing code, the backend can constantly push status updates down the pipe. 3. User interrupts. Because the pipe goes both ways, a user can hit stop generation, sending a signal up the pipe instantly to kill the LLM thread. REST for your control plane, RPC for your microservices, WebSockets for your real-time agent streams. Now that you have the mental model, let's jump into the code and see how FastAPI handles these connections. So we know the theory. REST is the menu, RPC is the walkie-talkie, and WebSockets are the chef's table. Now let's get our hands dirty. How to build the menu. Remember, REST is a noun-centric. We use it for our control plane, creating agents, fetching chat logs, and managing users. Because you are using FastAPI, this is where the framework absolutely shines. Let's look at the standard REST pattern for an AI backend. There are three critical things to notice here. First, the pedantic schema. This is our menu item. It defines the exact shape of the data. Pedantic guarantees that if the frontend sends a string instead of a float for the temperature, FastAPI will reject it before it ever touches your core logic. Second, look at the URLs /agents. Notice how it's a noun. We don't have a URL called /create agent or /fetch_agent. The URL is just the thing, and the HTTP verb post or get tells the kitchen what to do with it. Finally, the statelessness. Notice how every single endpoint requires the verify_token dependency. The kitchen has amnesia. Even if you just created an agent 1 millisecond ago, your next request to fetch it must include your ID badge again. Every request stands entirely on its own. Alright, we have our menu. Now let's grab the walkie-talkie. When your FastAPI server needs to talk to a dedicated Python microservice, maybe a heavy worker that searches vector databases or executes code, REST is too slow and bulky. We want RPC, specifically gRPC. Unlike REST, gRPC doesn't use JSON. It uses protocol buffers. Let's look at how that changes the code. Look here, this is a .proto file. Before writing any Python, we write a strict contract. Notice the naming convention. Execute search. It's a verb. It's an action. We aren't asking for a noun anymore. We are commanding the server to do something specific. Now look at the Python code here. When you compile that .proto file, it generates a Python class. All you have to do is override the execute search method. It looks exactly like a standard local Python function, but it is not. When your FastAPI orchestrator calls this, the data is compressed into binary, blasted over an HTTP2 connection, executed on a completely separate server, and the result is fired back instantly. No JSON passing overhead, no standard HTTP headers weighing it down, just raw walkie-talkie speed. Now the final one. How do we actually build the chefs table? Look at the foundational WebSockets endpoint. This is the exact pattern you will use to stream LLM tokens to your UI. Let's break this into 4 distinct phases. Phase 1, the handshake. Notice the decorator at app.websocket. We aren't using at app.get or at app.post anymore. When the clients hit this URL, they are asking to upgrade the connection. When we call await websocket.accept, the server agrees. The client just sat down at the chef's table. The HTTP request is now a persistent TCP pipe. Phase 2, the persistent loop. This is where the magic happens. We open a while true loop. This keeps the connection alive. The server sits here listening. When we call await websocket.receive_text, we are waiting for the user to send a prompt down the pipe. Phase 3, the stream. Once we have the prompt, we trigger our AI agent. Instead of waiting 10 seconds to send one massive string back, we loop through the output as it generates. Await websocket.send_text pushes chunks of text down the pipe instantly. This is how you build the typing effect you see in ChatGPT or Claude. It's happening in real time. Finally, we send a standard done flag so the UI knows the agent is finished thinking. Phase 4, the cleanup. What happens if the user closes their browser tab mid-generation? The connection breaks. FastAPI handles this beautifully with the WebSocket disconnect exception. If the pipe breaks, the code jumps out of the while loop, drops into this block, and safely shuts down without crashing your backend. The client has left the restaurant. Accept the handshake, loop to keep it alive, stream the tokens, handle the disconnect. And there you have it. Finally, you use REST for resources, you use RPC for your internal microservices, and you use WebSockets to stream real-time data to your users. Master these three and you have the foundation of true production-grade AI agentic architecture. Hope this is useful. See you in the next video.